For our instrument, we put two digital switches and an accelerometer into like a plastic kind of an iPhone case, and it's meant to replicate like an everyday object, which is basically like a Xbox or PlayStation controller. Which are two switches like your R1 and R2, and that's basically the instrument. And then we have all of the information coming into Max here, our Z-axis, Y-axis, and X. Then these are our switches left and right here, and then it's controlling various parts of like the jitter and the Csound. For the Csound, there's two instruments. One is a random noise generator, and the volume of that is controlled by the Z-axis. So it kind of acts like a shaker. The harder you shake it, it kind of is like a shaker for like an egg shaker on stage. And then the second instrument is like an FM synth. And then I have X, Y, and Z axis, and I have an octave shift as well, controlled by one of the switches. And the carrier frequency is controlled by the X axis, and the modular frequency is controlled by the Y axis. And then as well, I have one of the digital switches turned on a simple tape kind of delay, which works kind of cool as well. And then the X, Y, and Z axis are controlling various parts of the jitter, like for the jit.hatch, it's controlling the grid and threshold. For the rotor, it's controlling the spin speed, the X-axis offset, and the Y-axis offset. And then for the jit.plume effect, it's controlling the X and Y offset of the picture. Sorry. And then I'm just going to do a little demo, go into presentation mode. And then we just start it. Should be then with a simple fade in. Just fades in over 4 seconds. It should be louder than that for some reason. I don't know. You can hear the heavy tape delay there. Basically it, really. And then there's like 3 different speeds of a sequencer, which I control over all 3 with the digital switches, and they're also synced with the real-time clock. When the second they start, Csound and Max, where they trigger at different times, but at any time in the performance, I have complete control over all of the sequencer and any of the manipulation effects like X, Y, Z, carrier frequency, modular frequency, tape, delay, and everything.
Show you now. Here in our void setup, in these first 2 lines of code, we're just changing analog pin 0 to be 5 volt and analog pin 2 to be ground for the accelerometer. That's just to power it up and to ground it. And then here we're just doing it again. We're just declaring pin 0 high for 5 volt and pin 2, which is low, which is ground. And then here we're just declaring that that the input 10 and 9 are going to be the inputs for our switches. And then if we go down to our void loop, which is here, the first 3 phrases are doing bit shifting. So this will be reading the data for the Z-axis, this will be reading the data for the Y-axis, and this will be reading the data for the X-axis. And then these here, we're just bit shifting, splitting the data before we bring it into Max, and then we'll do more multiplication and addition in Max to get the full 10-bit value into Max. Then here we're just declaring that pins 10 and 9 are for our digital switches, which will be on and off. We're just doing that here, and then here we have a 5 millisecond delay before the data comes into Max. Here we have our first instrument, and it is a synthesizer, and we're doing some FM synthesis and some additive synthesis. And then here we're just declaring that our carrier frequency is going to be controlled by the X-axis, The modulation frequency is going to be controlled by the y-axis, and the modulation index is going to be controlled by the z-axis of the accelerometer. And here we're adding in an octave shift, which is going to be controlled by one of the digital switches on our controller. So here is just our synth. We have oscilli and f-oscilli and line seg. These are all just declaring different parts of the synthesizer, and then we're just adding our two synths here. Then if you come down here, we have our second instrument, which is a random noise generator, and we're declaring that the volume is going to be controlled by the z-axis of the accelerometer on the controller, and it's just declaring that it's random and it's at 3000 Hertz. And then we're just putting in a slight delay, and we're adding our delay and our volume together, and then it's all just going to come out and be controlled in real time in max via the Csound tilde. Then if you come down to the very end here, it's just declaring that both instruments will run for 300 seconds, which gives us plenty of time for 120-second performance.
For the final performance. Scale. Here in PNIC we have the values coming in from the Arduino. We have the z-axis, the y-axis and the x-axis, and the left and right switches. The Z, Y and X are going into a scale object, and to show you why, you can see that it scales so that it's ready for the performance. And then our switches here and here come out, and the left switch controls this octave shift here, and it also controls tape delay. And when the counter starts, we have a step sequencer here to control the audio, the sound coming out of Csound, and this select box triggers various events throughout the performance. Down here in Csound, the z-axis, the y-axis and the x-axis are controlling various aspects of it. The z-axis controls the the volume of the random noise generator, and the y-axis controls the modulation frequency, and the x-axis controls the index. That's as we showed you in the Csound. And then over in the jitter, the Z, Y and X axis are controlling various aspects of the three effects: jit.hatch, jit.plume and jit.rota. And you see them coming out here during the performance. And you can see that our performance fades in for 5 seconds, and then at 115 seconds it'll fade out the same, and that'll be the end of our performance. And just press L then to stop.